Here's a solution to a trig equation that might be similar to something you see in the homework. So we're supposed to find all solutions to the equation 6 tangent x minus 2 cotangent x equals 0 in the interval from 0 to 360 degrees. One thing, so when you're starting out solving a trigonometric equation, it's nice if you can express the equation completely in terms of just a single trigonometric function. And so one of the keys here would be to turn this cotangent x into 1 over tangent x. And I'll leave the rest of the equation the same on this step. So minus 2 times there's my cotangent x equals 0. Now something else I could do here is, well, let's see, I'm thinking about, there's several ways you could proceed from here. I guess maybe I'll look at it this way. Suppose I add the 2 over, I'm going to call this 2 over tangent x to both sides. So effectively moving this second term over to the right side of the equation. So that this becomes just 6 tangent x on the left side equals 2 over tangent x on the right side. Now I need to get that tangent x out of the denominator. It's at one point or another. And so I'm going to do that now by multiplying both sides of this equation by tangent x. And so I'm going to also multiply the left side of this equation by tangent x. I'm just trying to move this up. Okay, there you go. So now I have 6 tangent squared x equals, here the tangents cancel, equals 2. I could divide both sides by 6 so that I have tangent squared x equals 1/3 when you reduce that fraction. Now take the square root of both sides, and remember then that tangent x equals plus or minus the square root of 1/3. Which, since the square root of 1 is 1, I could write that as the square root of 1 over 3. Now it would be time to pull out your unit circle to find the solutions to this equation. I haven't copied in a full unit circle, but I'll kind of sketch out the positions that we need to refer to. Now, remember that tangent, the value of tangent is it's sine over cosine, which if sine of theta is given by the y-coordinate on the unit circle and cosine theta is given by the x-coordinate, then we're looking for when the ratio y over x in terms of points on the unit circle, oops, this is a y over x, is equal to either positive or negative 1 over the square root of 3. So you'll see that, first of all, in quadrant 1 at pi over 6 radians, which is 30 degrees. My brain just always goes directly to radians, but the instructions indicated we want to give our solution in degrees. At 30 degrees, you'll see coordinates square root of 3 over 2, 1/2. So that the value of tangent of 30 degrees is sine, which is 1/2, over cosine, which is the square root of 3 over 2. And now if I multiply top and bottom of that complex fraction by 2, I get 1 over the square root of 3. So 30 degrees is one solution. I'll run out of room there, but I'll worry about that later. Now also, over here at 150 degrees, you'll see coordinates, let's see, well, you see negative square root of 3 over 2, 1/2. So that the ratio sine over cosine would be equal to 1 over negative square root of 3. So negative 1 over the square root of 3. That would also satisfy this equation. So I want to add that. I guess I'll color code it here to the list. So you're going to find solutions also in quadrant 3 and in quadrant 4 at 210 degrees over here and at 330 degrees over here, where the ratio sine over cosine will also be, well, in quadrant 3, you're going to have sine is negative 1/2 over cosine is negative square root of 3 over 2. So you'll have a negative over negative. You'll end up with positive 1 over the square root of 3 at 210 degrees. And then at 330, x is positive, y is negative, so we'll have negative 1 over the square root of 3 as our ratio at 330 degrees. But so because of that plus or minus when we took square roots, these are all solutions to the equation. 210 degrees, 330 degrees.